Good morning. Today we'll discuss about D'Alembert's ratio test. If sigma un is a series of positive terms such that limit un plus 1 by un as n tends to infinite is L, it is convergent if L less than 1 and divergent if L greater than 1 and test fails when L is equal to 1. Okay. Now we'll discuss about problems. Sigma n by n power n. First you write nth term of this series. If it is given, then write down. If it is not given, you have to write nth term of this series. Here we have nth term is n by n power n. Okay. After that, calculate limit un plus 1 by un. That is, un plus 1 means you simply replace in nth term, replace n for n plus 1. N plus 1 by n plus 1 whole power n plus 1. This is un plus 1 by un. Un is n by n power n. So take the reciprocal and simplify. N plus 1 and n plus 1 got cancelled. N power n by n plus 1 whole power n by n. Now n power n by n plus 1 whole power n. So simply n take common in this bracket. N power n into 1 plus 1 by n whole power n into n power n by n. And now n power n got cancelled. We have 1 by n into 1 plus 1 by n whole power n. So separate limits. Limit n tends to infinite 1 by n into limit n tends to infinite 1 by 1 plus 1 by n whole power n. We know that 1 by n as n tends to infinite is 0 and limit n tends to infinite 1 plus 1 by n whole power n is e. So 0 into non-zero is 0 and we know that 0 is less than 1. According to the D'Alembert's ratio test, it is convergent. If the limit value less than 1, convergent. If the limit value is greater than 1, it is divergent. Now we go for another series 1 plus x by 2 plus x square by 5 plus x cube by 10 plus so on. This is a series of positive terms and write down nth term. Here not given nth term, so that you have to write x square x cube so on, so that you write x power n by 2 5 10 write down as n square plus 1. So when you take n for 1, what happened? X power 1 by 1 square plus 1. This is x by 2. Here first term to be neglected and n for 2 x square by 5 so on. Okay. So for neglecting first term, it's not affected the series, no problem. Now limit un plus 1 by un, which is x power n plus 1 by n plus 1 whole square plus 1. This is un plus 1 by un x power n by n square plus 1. And then calculate x power n plus 1 by n plus 1 whole square into n square plus 1 by x power n. Then x power n plus 1 by x power n. N taken into numerator. A power m by a power n can be written as a power m minus n. So x power n plus 1 minus n, and here n square taken out, here n taken out. Okay. Right. Now n square got cancelled. n got cancelled. Finally we have 1 plus 1 by n square into x by 1 plus 1 by n whole square plus 1 by n square. So as n tends to infinite, 1 by n square tends to 0. 1 plus 0 by 1 plus 0 whole square plus 0. So finally, the total value is 1 into x is x. By D'Alembert's ratio test, if the limit un plus 1 by un value is less than 1, convergent, greater than 1, divergent, and if it is equal to 1, test fail. So you write like this: by D'Alembert's ratio test, the series is convergent if x less than 1 and divergent if x greater than 1, and test fails if x equal to 1. Okay. Now check at x equal to 1. When x is 1, un, simply you put x for 1 here. Un is equal to 1 power n is 1 by n square plus 1. Okay. Now n square taken out. 1 by n square into 1 plus 1 by n square. Choose Vn as 1 by n square. Already we discussed a comparison test. So in the first video, I discussed many problems in comparison test. Now limit un by Vn as n tends to infinite, which is not equal to 0. So sigma Vn 1 by n square is convergent by P series because P is equal to 2, which is greater than 1. By comparison test, sigma un is convergent. So we conclude that the given series is converges if x less than or equal to 1 and diverges if x greater than 1. Okay. Because at x equal to 1 converges. So take the inequality at converges. Now go for another question. 3 power n by n into 2 power n. So un is 3 power n by n into 2 power n. Now calculate un plus 1 by un as n tends to infinite. So process is same and simplify it. So 3 power and 3 power n got cancelled, 2 power and 2 power n got cancelled, and finally we have 3n by n plus 1 into 2. Of course, as n tends to infinite, if both numerator and denominator degrees are same, then their coefficients ratio is the answer. Of course, that is a shortcut. And now you take n common, 1 plus 1 by n. n got cancelled, 3 by 2 into 1 plus 1 by n. Now as n tends to infinite, 1 by n tends to 0. So finally we have 3 by 2, whose value is 3 by 2 greater than 1. By D'Alembert's ratio test, the series is divergent. If the limit value less than 1, it is convergent. If the limit value greater than 1, then it is divergent. Go for another question. Sigma 3 power n into n square by n factorial. Here un is equal to 3 power n into n square by n factorial. Again calculate limit un plus 1 by un as n tends to infinite. Simply replace n for n plus 1, 3 power n plus 1, n plus 1 whole square by n plus 1 factorial. By un is 3 power n into n square by n factorial. So take the reciprocal, then 3 power n plus 1 written as 3 power n into 3, and n take common 1 plus 1 by n whole square. That is n square into 1 plus 1 by n whole square into n factorial. N plus 1 factorial can be written as n plus 1 into n factorial into n factorial by 3 power n square. Already I discussed n plus 1 factorial as n plus 1 into n factorial in my previous video. So that got cancel common terms, and we have finally 3 into 1 plus 1 by n whole square by n into 1 plus 1 by n is equal to limit n tends to infinite 3 into 1 plus 1 by n by n, because 1 plus 1 by n whole square 1 plus 1 by n got cancelled, we have only one term. Then apply limit for both the terms. Limit n tends to infinite into 1 by n, limit n tends to into infinite to 1 plus 1 by n. So this value is 0 and this value is 1 plus 0. 0 into non-zero is 0, which is less than 1. By D'Alembert's ratio test, the series is convergent. Now test for the convergence sigma x power 2n minus 2 by root n into n plus 1. Again, you write this is a series of positive terms and write down nth term, then calculate un plus 1 by un as n tends to infinity. The process is same. Then simplify. Again, a power m by a power n is a power m minus n. Then n take common, n into 1 plus 1 by n. Here also n take common, n take common. Finally, root n square is n. Here also root n square is n. Now cancel n, both numerator and denominator. So as n tends to infinite, 1 by n tends to 0. Root 1 is 1, root 1 is 1. So finally, we have x square. Now the value is x square. According to the D'Alembert's ratio test, if limit un plus 1 by un value is less than 1 convergent, greater than 1 divergent, equal to 1 test fail. So by D'Alembert's ratio test, the series is convergent if x square less than 1 and divergent if x square greater than 1, and test fails if x square is equal to 1. So discuss at x square is equal to 1, because it fails at x square is equal to 1. So when x square is equal to 1, un is 1 by root n into n plus 1. Again apply comparison test. Simply n taken out, which is n square, root n square is n, taken out 1 plus 1 by n. You take Vn as 1 by n. Un by Vn as n tends to infinite is not equal to 0. If un by Vn as n tends to infinite is not equal to 0, then go for Vn. Our choosing Vn is divergent by P series because whose P value is 1. By comparison test, sigma un is divergent. Therefore, sigma un converges if x less than 1 and diverges, that is simply right, sigma un converges if x less than 1, diverges if x square greater than or equal to 1. Simply sigma un converges if x square less than 1 and diverges if x square greater than or equal to 1. This is for homework. Thank you.